Hello my dear friends, welcome back to our YouTube channel. This is your ADC Max. Thanks for your constant support to make me further more videos. This video is the continuation of the inverse Z transforms using residue theorem. I made one more video. I introduced what is meant by the residues, how to get the residues and poles, types of singular points, everything. Please go and watch the video I made one for the introducing the poles, the singular points, analytic functions, etc. etc. So it is on the board. This is the way to determine the inverse Z transform by using the residue theorem. Is nothing but sum of the x of z into z power n minus 1 at each of its poles. So how to determine the residue value? So this is the formula for the residue of the pole at the order n. At the order n, if n equal to 1, it is called the simple pole. That's it. Okay. Now to see this question, is the inverse of z into z plus 1 by z minus 1 whole power 3. Power 3 is there. So this is my x of z, isn't it? This is my x of z. What's a pole? What's a pole? The pole of x of z are given by the denominator term. Z minus 1 whole power 3 is equal to 0. So what's in the power 3? Power 3 means repetition. It's called the order. So by this case, we will get z is equal to 1 of order 3. So the pole is 1 but is repeated thrice. So here the order is 3. So can you use the first formula, the place of n equal to 3 and a equal to 1, we will get the answer. So let us see that. Now find out the residue of x of z into z power n minus 1 at the pole z is equal to 1 and the order n is equal to 3. So order is n is equal to 3. So n means n minus 1 factorial, n minus 1 differentiation. So now this time n equal to 3. So substitute n equal to 3, we get 3 minus 1 factorial. Limit z tends to 1 and 2 times differentiation, because n means n minus 1 time differentiation. Here n equal to 3. So this 2 times differentiation, d squared by dz square of z minus 1 whole power 3 and x of z into z plus 1 by z minus 1 whole power 3 into z power n minus 1. Is it right? Is it right, sir? This is x of z, this is z power n minus 1. So before going to the differentiation, just try to cancel the term z minus 1, z minus 1 will be cancelled, and just combine this z into z power n minus 1, this becomes z power n. So behind the term we have 1 by 2 factorial, limit z tends to 1, d squared z by dz squared of z power n minus 1 and z power n. Let us multiply into the term. What happened? Z power n plus 1 plus z power n. Is right? So once again repeat this. Z power n minus 1 is z power n. Z power n into z power 1 is z power n plus 1. Z power n into 1 is z power n. Now I am going to differentiate this 2 times, then apply the limit. So that's the concept. So 1 by 2 factorial is 2. So limit z tends to 1. The first time differentiation, n plus 1 getting down by n plus n into z power n minus 1. Differentiating with respect to z. First time. Once again differentiate this with respect to z. Once again differentiate this with respect to z. So n plus 1 already there. And this time n getting down. Z power n minus 1 plus n is already there, n minus 1 into z power n minus 2. Now substitute n equal to, z equal to 1, we get 1 by 2 into, putting z equal to 1, 1 power n minus 1, it is 1 only, so it is n into n plus 1 plus n into n minus 2. Z equal to 1, so 1 power n minus 1, 1 power n minus 2 is equal to 1 only. So right, is right, 1 power n minus 1 is equal to 1 power n minus 2 is equal to 1 only. No problem, it's 1 only. Now let us simplify this. What we will get? I think so. N into n squared, n into 1 is n into n squared is n squared is n minus 1. So it is 1 by 2 into n squared plus n squared minus n. So after cancellation of the n, we get 2n squared. So 2n squared, so it is 1 by 2 into 2n squared. So we get the answer is n squared. So what is the answer for z inverse of z into z plus 1 by z minus 1 whole power 3 is equal to z square, it is n square. But some of you, if you know already the z transform of n square, yeah, we got this z transform of n square is nothing but z into z plus 1 by z minus 1 whole power 3 by using the formula n into f of n equal to minus z into d by dz of f of z. So once if you use this formula for z transform of n, what's z transform of n? Z by z minus 1 whole square. So by using this result in this formula, you will get this answer. I made a separate video for z transform of n squared, even though I get the same answer. But if you don't know the z transform result, then we directly apply the residual method, you will get the answer, the same answer. So that is the beauty of this residue theorem. So that's why I told you that this is the one of the very interesting method to determine the inverse z transform without knowing the basic results. Without knowing the basic results. So that is the concept. Okay. Thank you so much for watching our YouTube channel. This is your ADC Maths. Bye. Take care.